Hi, I am Dr. Shyam Sarkar. In this lecture, I am going to discuss MCQ from atomic and molecular term symbol. This is a very important topic because in most of the competitive exam like CSIR-NET, GATE, SET, IIT JAM, BARC, even in college and university level exam, one question is very common from this portion. Okay. Before going to the question answer discussion, I would like to mention that who have not seen my previous video lecture on this term symbol, you may go through that lecture because you will get an idea about the method of term symbol calculation in details. Okay, so I have given the link for that video in the description box. You may check it out. Now, I'll discuss previous year question answer one by one for various competitive exam like NET, SET, GATE, JAM. Then I will discuss few sample question answer discussion as a suggestion for your upcoming exams. Okay. So let's start with the CSIR-NET. So let us see the first question. Here, see, the lowest energy state of a 1s1 2s1 electronic configuration according to Horn's rule is. So four options are given. Now let us see how can we get the correct answer. See, electronic configuration is 1s1 2s1. So total S, that is total spin quantum number, will be s1 plus s2, that is half plus half, equal to 1, and total spin multiplicity, that is 2s plus 1. If you put the value of s1 here, you will get 2s plus 1 equal to 3. So spin multiplicity is 3. Then you can easily cross option B and option D because in both of them spin multiplicity is 1. Okay, so answer will be between A and C. So now you have to calculate L values. So L equal to L1 plus L2, that means 0 plus 0, because for S orbital L equal to 0, which implies the term S. You can see this chart, for different L values there are different terms. So for L equal to 0, term will be S. Okay, so 3S will be the term, state term. Okay, now you have to calculate J because in both of them J are different. So J equal to L plus S to L minus S, that is it will be 1 for in both the cases. Okay, so the correct answer will be 3s1. So option C is the right answer here. Okay, let's move to the next question. Here, see, the highest molecular orbital for an excited electronic configuration of the oxygen molecule are 1 pi g1, 3 sigma u1, and a possible molecular term symbol for oxygen with this electronic configuration is. Four options are given. See, they asked for a possible molecular term symbol. Okay, so let us see how can we get this answer. See, electrons are in pi and sigma orbitals. One is in the pi orbital and another one is in the sigma orbital. Now we know that lambda values for pi orbital is plus minus 1 and lambda value for sigma is 0. Now in this case, total orbital angular momentum capital lambda equal to plus 1 plus 0, that is 1. 1 implies the term pi. You can see from this chart. So for different values of capital lambda, there are different terms for molecular term symbol. Okay, see here you got pi. So if once you got pi, then you can cross all the three options B, C, D, because see only one option is left with pi, so A will be the correct answer. So without calculation you can predict A is the correct answer. Still I will show you the total calculation. Okay, see since two electrons are there in different orbitals, so those two electrons may have same spin or opposite spins. For same spin, total multiplicity, that is 2s plus 1 equal to 3, and for opposite spin, that is 2s plus 1 equal to 1. So there will be two possible term symbols, that is 1 pi and 3 pi. Okay, so since here option is given with 1 pi, So the correct answer will be option A, 1 pi. Okay, so you can do full calculation or without calculation. If you have different options, then you can easily predict the correct answer here. Okay, so let's see next question. The possible term symbols of excited states of sodium atom with the electronic configuration 1s2, 2s2, 2p6, 3p1 is or are. See, 4 options are there. So this is very easy question, because if you see the electronic configuration, there is only one electron in the 3p orbital. So we will consider only outer electron part only. Okay, so S equal to half here for one electron, that is total spin multiplicity 2s plus 1 equal to 2, and L equal to 1, because for p orbital L equal to 1. Okay, so when L equal to 1, then the term will be p, because we know that from that chart for L equal to 1 the term is p. Okay, now you can cross the two options A, C and D. Okay, why? Because see 2p, so 2p is not there any of the options like A, C, D. So from this point you can get correct answer is B, but still I will show the total calculation or full calculation. See how it's coming, 2p 3 by 2 and 2p half. Okay, so you have to calculate J for that, and you know that J equal to L plus S to L minus S. See 1 plus half to 1 minus half, that means 3 by 2 and half. So if you put these values, so you will get the term symbols are 2p 3 by 2 and 2p half. Okay, so let's move to the next question. The lowest energy state of an atom with electronic configuration ns1 np1 has a term symbol. So similarly 4 options are there. So since electronic configuration is ns1 np1, so S equal to half plus half equal to 1, that is total spin multiplicity 2s plus 1 equal to 3 here, and L see all electrons, one electron is in the s orbital and another electron is the p orbital. So L equal to 0 plus 1, because L equal to 0 for S and 1 for L. So total capital L will be 1. That means the term will be P here. Okay, now you have to calculate J values. J equal to L plus S to L minus 1. That means 1 plus 1 to 1 minus 1. That means you will have 3 different J values, 2, 1, 0. Now which J we should consider? You have to see the outermost orbital electron is np1. np1, p1 means less than half filled. So minimum J value you should consider here. So minimum J value is 0. So the lowest energy state term symbol will be the 3p0. So option D is the correct answer. Okay, so next question. The term symbol for the first excited state of beryllium with configuration 1s2, 2s1, 3s1 is. So among these 4 options, let us see which one will be the correct answer. Since configuration is 1s2, 2s2, 3s1 and S equal to half plus half, because 2s1, 3s1, these 2 electrons we will consider half plus half equal to 1, and spin multiplicity is 2s plus 1 equal to 3, and L equal to 0, because for s orbital, see both 2s 3s both s orbital, so L equal to 0 here, which implies the term S. Okay, now J value, see L plus S to L minus S, that means 0 plus 1 to 0 minus 1, and J value is 1. So the term symbol is 3s1. That means option A is the right answer. Okay, next question. See, the term symbol that is not allowed for np2 is, see, not allowed. You have to see the question very clearly, not. So see, the 4 options are here. Let us see the answer. See, here you have to do back calculation. Back calculation means for 1d, what will be the electronic configuration or electron arrangement of electrons in the orbital. Let us see for 1d. 1d means, see, 1 means 2s plus 1, that is spin multiplicity 1. When spin multiplicity comes 1, at that time when total spin S equal to 0, right? 2s plus 1, that means if S is 0, then 2s plus 1 equal to 1. So 1d, 1 for electron when they are with the opposite spin, then only you will have s equal to 0. Now d, for d, how d comes? spd, l equal to 0, 1, 2. So when l equal to 2, then the symbol comes d. Okay, so when l will be 2, see, if you put 2 electrons in px orbital subshell, then you will have 1 plus 1, that means total l will be 2. So like this you can do for other 3 options also. For 3p, see, the electronic configuration will be like this, and for 1s like this, and for 3d like this. So I have shown for 4 options electronic arrangements are in this way. Okay, now you have to see which electronic configuration or which electronic arrangement is not possible at all. See, in the first 3, these are okay, but in the last one, 3d, see, both the electrons with the same spin in a subshell. So this is the violation of Pauling exclusion principle, because Pauli exclusion principle says that 2 electrons in an orbital cannot have the same spin quantum number. If one is plus half, another must have to be minus half. That means if one is having spin in the upward direction, the other one must have in the downward direction. So this option D will not be the allowed for NP2 configuration. Okay, so here correct answer is 3D, that is option D. Now let's move to the next question. Here, for an electronic configuration of 2 non-equivalent electrons, see, non-equivalent, pi 1, pi 1, both are in the pi orbital. Okay, which of the following terms is not possible? Here also negative again, so not possible. Okay, let us see which configuration, which term is not possible. So for that, see, since both the electrons are in the pi orbital, and we know that for pi orbital lambda value is plus minus 1. Okay, so total angular momentum, that is capital lambda, will be plus 1 and minus 1, that is 0, and plus 1 plus 1, that is 2. If this is 0, then the symbol will be sigma, and if lambda, capital lambda, is 2, then the symbol will be delta. Now see, from this you can say the answer. See, in the which is not possible. So see, if you look at these 4 options, option A, C, B, see, in these 3 options are with sigma and delta, and in option D, see, it's with phi, so you can easily say that the 3 phi will not be the possible for this type of configuration. So D is the right answer. So 3 phi is impossible term symbol for this type of configuration, and here D is the correct answer. Okay, so let's see next question. So next we will see the question with the previous year solve of West Bengal set. See, the first question of West Bengal set 2020, the ground state term symbol for samarium 3+. So for lanthanides, they asked for ground state term symbol. For lanthanides, see, you must know the electronic configuration of lanthanide ion. Okay, so for your convenience, I have shown here the electronic configuration of all the lanthanide ion. You can have a screenshot of this, because this will help you for the determination of term symbol of any lanthanide ion, because they are generally in the +3 oxidation state. So if you have the idea of electronic configuration of lanthanide 3+ ion, then easily you can have you can calculate term symbol. Okay, so for this, see, we need electronic configuration of samarium. So samarium is 4f5. Okay, so 4f5 means, you can see the electronic arrangement here. So all the electrons are unpaired in the f orbital, and s equal to 5.5, and 2s plus 1, that is total spin multiplicity, is 6. Now see, 6 means you can cross 3 options, A, C and D. So B will be the correct answer because only one option is there with the 6 spin multiplicity. So you no need to do further calculation in exam, but for your convenience I will show you here. But if you have different options other than 6 spin multiplicity, you can easily cross and you will have the correct answer, option B. But still I will show the full calculation here. See, L equal to 5 because small l equal to 3 for F orbital. You can see from this arrangement how I have calculated L equal to 5. So 5 means the term will be H. Okay. So J, what is J? J is L plus S to L minus S. So 5 plus 5 by 2 and 5 minus 5 by 2, in between these two J values will be. So see, 15 by 2, 13 by 2, 11 by 2, 9 by 2, 7 by 2, 5 by 2. Now which J value we should consider? See, F5 means less than half filled. Okay, so less than half filled means minimum J value we should consider. So the term symbol will be 6H5 by 2 and option B is the correct answer. Okay, so next question. See, the ground state term for cerium 3 plus is. So here they ask for cerium. So if you look at that previous table, you can see for cerium the electronic configuration is 4f1. So 4f1 electronic configuration means one electron is there, so small s equal to half and capital S equal to half also, and 2s plus 1 equal to 2. So total spin multiplicity is 2, and if 2 is there in the option A and B, so you can easily cross option C and D. Okay, so correct answer will be between A and B. So let us see. For that you need to calculate J values. Okay, so first you have L equal to 3, which implies the term F. This is very common, so I am not discussing in details. So let us go to the J calculation. J equal to L plus S to L minus S. So 3 plus half to 3 minus half, 7 by 2, 5 by 2. Now see, this is again less than half filled. So minimum J value we should consider. So this is 5 by 2. So the correct answer will be 2F 5 by 2. That is option A is the correct answer here. See the next question. The ground state term of a lanthanide ion is 2F5 by 2 and the lanthanide ion is. Here see, they have given term symbol. They asked for the which lanthanide ions is having 2F5 by 2 term symbol in the ground state. Okay, so we have to do reverse calculation. So for this calculation we will see the 2s plus 1, that is total spin multiplicity, is given 2. Now if you do not know S values, you can calculate the S values from here. S equal to half. See, if you do back calculation, you will get S equal to half here. Okay, now the term F means we know that for L equal to 3 the term comes F. So F means L equal to 3. Now L equal to 3 and S we got 2. So J values is L plus 2 L minus 1, that is 3 plus half, 2 3 minus half, that is 7 by 2 and 5 by 2. Now see, we have they have given that 2F 5 by 2 as the ground state term symbol. 5 by 2 means, see, this is minimum value of J, because since minimum value of J, so there will be the less than half filled orbital. So less than half filled means, see here S equal to half. S equal to half means for a single electron. For a single electron means electronic configuration will be F1, and F1 corresponds to the cerium ion. So option D is the right answer here, and the lanthanides will be cerium 3 plus ion. Okay, so in this way you can do the back calculation, you will get correct answer. This is not tough, this is very easy. Okay, so let's see next question. The term symbol corresponding to an ND10 electronic configuration is. See, ND10, this is very simple. So ND10 means all electrons are paired up. So S equal to 0 here and 2s plus 1 equal to 1. So when 2s plus 1 equal to 1, see spin multiplicity 1 means you can cross all the three options A, C, B. So D is the correct answer. So you no need to do further calculation in exam, but I will show you the full length calculation. Okay. See L equal to 0 here, which implies the term S, and J equal to L plus S to L minus S. If you put the value of L and S, you will get J equal to 0. So the term symbol is 1s0, and here D is the right answer. Okay. So next question, states arising from 2p electrons. See 2p electrons means p orbital but 2 electrons, but they have not said which in which subshell electrons are there. So they have given 4 options. You have to identify which option is correct. Okay. So 2 electrons in a p orbital may have the same spin or opposite spin. So you have to calculate for both. Since for same spin S equal to half plus half 1, but for opposite spin half minus half 0. So S equal to 1 for same spin and S equal to 0 for opposite spin. Now 2s plus 1, that is spin multiplicity for same spin is 3, and for opposite spin 2s plus 1, that is spin multiplicity is 1. Okay. Now see for p orbital L equal to 1, small l equal to 1, thus capital L will be the L1 plus L2 to L1 minus L2. So there will be 3 values of L, 2, 1, 0. If you put small L1 and L2 here, you will get 3 values of L, that is 2, 1, 0. Okay. Now which implies, see 2, 1, 0 means there will be 3 different symbols like S, P, D. Okay. For L equal to 0 S, for L equal to 1 P, and for L equal to 2, that symbol will be D. So the possible term symbols will be 3D, 3P, 3S, 1D, 1P, 1S. So among these 6, so 3 will be the states, stable state. Okay, the valid states. 3 and another 3 will not be valid for 2p electrons. Let us see which 3 will be valid. So for that, again you have to do back calculation for the electronic arrangement. So here I have shown you 6 possible term symbols, 6 different orientation of electrons in the orbital. If you see for 3D, see 2 electrons with the same spin in an orbital. So this is not valid. So you can cross this. Now for 1D, okay, this is correct. For 3P, this is also correct. For 1P, see 1P is not also valid, because this type of arrangement is the violation of Pauli exclusion principle as well as Hund's rule. Okay. For 3S also, see this is also is not valid. This is also violation of Pauli exclusion principle. So the correct answer will be D, that is 3P, 1D and 1S. So these 3 are the states arising from 2p electrons. So D is the correct answer here. Okay. Now I will show you previous year solved for IIT JAM. See this question, the ground state term for a Phi ion with D7 electronic configuration is. So D7 means, see there are 3 unpaired electrons, and in the 2 orbital there are paired electrons. So let us see the S values. S equal to 3.5, because for 3 electron, other 4 electrons S will be 0. So S equal to 3/2 here, and 2s plus 1 is 4, that is total spin multiplicity is 4. Okay. So L equal to 3, capital L is 3, and which implies the term F. Okay. And J is equal to L plus S to L minus S, 3 plus 3.5 to 3 minus 3.5, that is 9/2, 7/2, 5/2 and 3/2. Now see the 3D7, that means it has more than half fielded electrons in the d orbital. So maximum J value we should consider here. So the term symbol will be 4f9 by 2. So the option B is the correct answer here. Okay. Now see the previous year solve of GATE exam. So let us see which type of question asked in the GATE. The ground state term for chromium ion in chromium CN6 4- complex is, four options are there. So here see, this is not free ion, this is chromium ion is complex. Also oxidation state of chromium is not given. They asked for chromium ion. So let us see. So chromium is in +2 oxidation state here, having electronic configuration 4s0 3d4. Okay, you can see the electronic arrangement here. Now L equal to 2 plus 1 plus 0 minus 1, that is 2. 2 means the term will be D. Okay, so this is for free ion, and the spin multiplicity is, see, from this type of arrangement 5, 2s plus 1 equal to 5. Thus the ground state term for chromium 2 plus is 5d. So most of the student make mistake here, they will take 5d. But you should remember here chromium ion is not at all free ion. This is in a complex. So you have to consider the complex. That means you have to consider the ligands attached with the chromium ion. So you have to consider here this complex as octahedral complex CrCN6 4-. Now, so 5D is not right answer. You have to consider the ligand field. So with this octahedral ligand field, so the presence of Cn- makes the electron paired in T2g orbital. If you see the electronic configuration here, in T2g orbital, one electron is getting paired up. Okay, now this orientation of electrons getting changed, so L will be also changed. So now L equal to 5, which implies the term H. Okay, H. Now you have to see the spin multiplicity, total spin multiplicity 2s plus 1 equal to 3, 2s plus 1 equal to 3, because here 2 unpaired electrons, that means half plus half equal to 1. Now 2s plus 1 equal to 3. Thus the ground state term symbol for this chromium 2 plus ion in this complex is 3H. So option B is the right answer. So remember very clearly, when free ion is there, their ground state term symbol will be different from that of complex depending upon the ligand. Okay, whether this is strong field or weak field ligand. Okay, next, see the ground state term for vanadium 3 plus ion. So four options are there. So let us see. For vanadium 3 plus, the configuration is 3d2, and 3d2 means S equal to half plus half, that is spin multiplicity 2s plus 1 equal to 3, and L, capital L equal to 2 plus 1, electrons are in the first two, so total L equal to 3, which implies the term F. So 3F will be the right answer, that is option A is the right answer here. Okay, now I will go to the sample question, which you can take as suggestion from my side. Okay, see the ground state term symbol for europium 3 plus ion is. So for europium ion you need to know the electronic configuration. So I have already given the table. So from that table you can see the electronic configuration is for europium 3 plus ion is 4f6. So 4f6 means the S is 3, capital S, that means total spin is 3, that is 2s plus 1, total spin multiplicity is 7. Okay, total spin multiplicity 7 means you can cross option C and option D, because in option A and B the spin multiplicity is given 7. Now you have to calculate L. So L is here 3. So L3 means F. So the term will be 7F. So in both cases 7F is there. So you need to calculate J also. So for J values for this configuration is from 6 to 0, 6, 5, 4, 3, 2, 1, 0. Okay. So among these 7 J values, you need to see which one you need to consider. So as I said, here electronic configuration is 4f6. Okay, so minimum value of J we should consider, because this is less than half fielded configuration. So with the minimum value of J, the term symbol becomes 7f0. That is option A is the correct answer here. Okay. Now see, the lowest excited state of the helium atom has a term symbol. Let us see which one is the right answer here. For helium, see, first lowest excited state. Okay, so excited state means electronic configuration is 1s1 2s1. Okay, now s equal to, see, half plus half equal to 1, and total spin multiplicity 2s plus 1 equal to 3. So then L, you have to calculate L. L is 0 here because electrons are in the s orbital. Both the electrons are in the s orbital. So L equal to 0 here. Okay. So 0 means you will get the term s. Okay. Now you have to calculate J. See, J is L plus s to L minus 1. If you put the value of L and s, you will get the J value is 1. So 3s1 is the correct answer here. So option C is the correct answer. Okay. Let's see the next question. Arrange states according to the increasing energy level. So there are 4 options are there, and 4 energy levels are given. You have to arrange according to the increasing energy level. So this type of question is slightly different from the other questions. Here I have put because this is new type of question, it may also come. So let us see. So for this answer, you need to know Hund's rule regarding the term symbol. So Hund's rule says that the energy of the states decreases as the spin multiplicity increases. So with the increase of the spin multiplicity, the energy of the state decreases. That is, the ground state of an atom should therefore show highest spin multiplicity. So ground state will have highest spin multiplicity, and they will possess the maximum number of unpaired electrons. And rule number 2, when the value of spin multiplicity is same, that means many state is having same spin multiplicity, then you have to go for the L values. Okay, so when values of spin multiplicity is same for more than one state, the state with the highest value of L has the minimum energy. So you have to see which one is having highest L values, that will have minimum energy. Okay, so now here 4 options are given: 1G, 3F, 1D and 3P. These 4 states are given. So see, among these 4, the highest spin multiplicity is in 3F and 3P. In both cases 3. So 3F, 3P, when spin multiplicity is same, you have to see L values. So L equal to 3 for F and L equal to 1 for P. Okay. Now see, 3 means this is greater, so it will have the less energy. So energy of 3F is less than 3P. Okay. Now we will go for 1G and 1D. So 1G, 1D, they have spin multiplicity same 1. So L equal to 4 for G and L equal to 2 for D. So see, 4 means greater than 2 values. That means that 1G will have less energy than 1D. Now if you arrange all these 4, you will get the order 3F less than 3P less than 1G less than 1D. So this matches with the option D. So option D is the correct answer here. Okay. So next question. The term symbol for the ground state of He2 plus ion. See, He2 plus ion means here you have to go with the molecular term symbol. So this is molecular level term symbol. See, for molecular orbital electronic configuration for He2 plus, so sigma 1s2g and sigma 1s star 1u. So symmetry is different. The electronic configuration is in this way. Again, I would say, if you watch my previous video, you will have idea, okay, about the calculation of molecular term symbol. So from that, I have written here the electronic configuration of He2 plus ion and the symmetry of corresponding orbitals, that is G-red or un-G-red. So since electrons is in the sigma orbital, see electron is in the sigma orbital because we are consider only last electron field in the orbital, that is sigma star 1s1u. So we will consider only this electron. So this is in sigma orbital. So the orbital angular momentum capital lambda is 0 here, which implies the term sigma. Okay. Now see spin multiplicity 2s plus 1, see s equal to half, so 2s plus 1 equal to 2. So the term symbol will be 2 sigma plus u, 2 sigma plus u, because u is ungeared symmetry for sigma star orbitals, and plus is used for when electron is in the sigma orbital. You can see from my previous video I have given rules for the determination of molecular term symbol. So there I said that plus symbol will be only used for sigma, plus and minus, but here plus will be used because electrons are in the sigma orbital. So the right answer will be 2 sigma plus u. Okay, so it matches with the option A. So option A is the right answer. So next, see the next question. The term symbol for the ground state of oxygen molecule is 2 sigma plus u, 2 sigma minus u, 3 sigma minus g, 3 sigma plus g. So 4 options are there. So let us see the molecular orbital electronic configuration of O2. So is given here. We will consider only the last portion, that is pi star 1 to px equal to pi star 1 to pyg. So this is the electrons we have to consider for the calculation of molecular term symbol. So you can see the electronic arrangement from here. Now the total orbital angular momentum lambda equal to plus 1 minus 1, that is 0. 0 means it implies the term sigma, capital sigma. Now 2s plus 1 equal to 3, because half plus half equal to 1. So s equal to 1, that means 2s plus 1 total spin multiplicity is 3. So the molecular term symbol will be 3 sigma. This sigma is capital sigma, Greek letter, capital Greek letter. So 3 sigma minus g. G, see I have given already ungeared symmetry. Okay, and minus sign. Why minus sign? Minus sign comes because electrons are in the unfilled pi orbitals. Okay, so electrons are in the unfilled condition of the pi orbitals. That's why minus sign is used. So 3 sigma minus g is the correct answer. So option C is the correct answer here. Okay, so here I have discussed varieties of question so that you can easily solve in any exam. Okay, so here I conclude with the 20 MCQ question of answer discussion, and thank you for watching this video.